You know that meeting, right? The one where everyone's arguing about which AI prompt is better? This one sounds more direct. Yeah, but that one is more empathetic. It's always a classic case of really strong opinions, but zero data. Well, today we're going to end that debate, not with more opinions, but with a simple, powerful process that lets the data do all the talking. So let's get into it. So to get us from just guessing to actually knowing, we're going to follow a clear path. First, we'll tackle the main problem, opinion versus data. Then, we'll build our playbook with 4 core principles. We'll see how it all works in the real world, learn how to tell a real result from just random noise, and we'll even walk through a test step by step. And finally, we'll make a decision backed entirely by data. All right, let's kick things off. Opinion versus data. See, at the heart of this whole thing is a really basic conflict. It's that classic battle between our gut feelings, what we think should work, and the cold hard proof of what actually works. This quote from our source material just nails it. These debates produce strong opinions but zero data. I mean, think about it. We've all been there, right? Wasting hours arguing over tiny word changes or which AI just feels smarter. But without any numbers to back it up, we're just running on vibes, not facts. And that's the big question, isn't it? How do we stop this guessing game, cut through all that noise, and find a way to definitively prove that a change we're making is actually an improvement? Well, the answer is actually pretty simple and incredibly powerful: A/B testing. It just stops the debate cold. You test both versions side by side, you measure the results, and you let the data tell you who the winner is. Suddenly, opinion doesn't matter anymore. Now, if you want to do this right, you need a playbook. These principles seem simple on the surface, but trust me, they require discipline. So let's break down the 4 core rules that are the foundation of every single successful test. Here they are, the 4 pillars of our playbook. Think of this as your recipe for a result you can actually trust. You need a clear hypothesis. You have to change only one variable. You need consistent measurement and a big enough sample size. If you mess up even one of these, the whole thing kind of falls apart. So let's look at each one. First up, a clear hypothesis. Before you even start, you have to write down exactly what you expect to happen. This is so important for 2 reasons. 1, it forces you to define what success actually looks like. And 2, it stops you from changing the rules later just because you didn't like the results. It keeps you honest. Okay, listen up, because this next one is the golden rule. It is absolutely non-negotiable. Change only one thing at a time. Seriously, if you test a new prompt and a new AI tool at the same time, your results are completely useless. Was it the prompt? Was it the tool? You'll never know. You have to isolate the one thing you're testing to get a clean result. Principle 3 is all about getting away from vague feelings. You can't just say you want better outputs. That's an opinion, not a metric. You need something concrete you can count. Is it the percentage of outputs that don't need revision? The time saved? A user satisfaction score? Whatever you pick, you have to apply that exact same measurement to both version A and version B. And finally, how much data do you actually need? Well, a really good rule of thumb is to aim for at least 30 to 50 samples for each version you're testing. Why that number? Well, that's kind of the magic point where you start to smooth out the randomness and luck and you begin to see a real trustworthy pattern emerge. Now, this is super interesting. This chart shows you a key relationship. The bigger the change you're looking for, the less data you actually need to find it. It's like trying to spot a whale versus a goldfish in the ocean. If you expect a massive 50% improvement, it's so obvious you might see it in just 10 or 15 tries. But if you're hunting for a tiny 10% improvement, you're going to need a much bigger sample, like over 100, to be sure it's real and not just a fluke. Okay, so we've got the theory down. Now let's put it into practice. How do these principles actually work in the real world when you're testing different prompts, or maybe comparing tools, or even changing up your whole workflow? And this slide just illustrates that discipline perfectly. Take a look at the left. If you're testing prompts, the only thing that changes is the prompt itself. Everything else, the AI tool, the input, how you judge it, is totally locked down. Now look at the right. If you're testing tools, the tool is the only thing that changes. See? It's that simple and not strict. Now here's a fantastic pro tip that can save you a ton of money. It is so easy to just chase the highest quality score, but that can be a trap. I mean, if tool B is 3% better but costs 10 times more, is that really a smart decision? Probably not. The real metric you should be obsessed with is cost effectiveness. That's where you find the true value. All right, so you've run your test. Version B scores a 4.3 and version A gets a 4.2. Victory! Time to roll it out to everyone, right? Well, hold on a second. How do we know that tiny little difference wasn't just luck? We need a way to separate the real signal of an improvement from the background noise of just random chance. And this is where we use a tool called statistical significance. It sounds complicated, but it's just a fancy way of calculating the odds that your result was a total fluke. The industry standard is to aim for 95% confidence. All that means is you want to be 95% sure that the winner really won, and there's less than a 5% chance it was just random luck. I love this analogy because it makes it so clear. If you flip a coin 100 times, you don't expect exactly 50 heads, right? Getting 53, that's just normal random variation. That's noise. But if you get 80 heads, whoa, that's a strong signal that something weird is going on with that coin. Statistical significance just helps us find the line between normal noise and a real significant difference. And here's the best part. You do not have to be a math whiz to do this. There are tons of free calculators online for this exact thing. You just plug in your numbers for version A and version B, just like you see here, and it does all the complicated math for you. It'll just spit out a simple yes or no on whether your result is significant. Okay, enough theory. Let's make this real. We're going to walk through a complete A/B test example together, from the very beginning all the way to the final result. So, here's our scenario. We're testing two different prompts for writing customer service emails. Version A is super simple, write a helpful response. But version B is way more detailed and structured. So following our rules, our hypothesis is clear. We believe the detailed prompt, version B, is going to produce better responses. And after running 50 customer emails through both prompts, the results are in. And wow, the data is crystal clear. Just look at this. Across every single metric we measured, the detailed prompt, version B, was the decisive winner. It was better at addressing the customer's concern, way better at matching our brand voice, and it got a higher overall quality score. This isn't an opinion anymore. It's a clear, data-driven win. So let's bring it all home. We've gone over the principles, the process, and a real-world example. What's the one key thing to take away from all this that turns it from just a cool experiment into a powerful, regular practice? It all comes down to this simple checklist. This is it. This is the entire framework that gets you out of those pointless opinion-based debates for good. You start with a hypothesis, you isolate one variable, you measure it consistently, you get enough data, you check for significance, and then, and only then, you make your decision. This is how you stop guessing and start building an AI strategy that you can prove actually works. So, I'll leave you with this one question. Think about your own team, your own projects. What is that one argument, that one long-standing debate about a prompt or a tool or a workflow that you're now ready to go out and finally settle with some cold, hard data?